All right. So, for one case, we get the p-value. We get the p-value for this case, okay? Because the p-value is large, is 60%. We consider this is just a bad luck out of 60%. It's just a random chance. There are 60% possibility this happens. It's a big possibility. Okay? So if it's a drug, if we are testing a drug, we say, only two patients out of 5 die. So now we should sell this drug to the world. We should sell this drug to the world. But the scientific argument is this is not enough evidence to show this drug lower the mortality rate. So you guys were hanging out with Mir, right? You were hanging out with Mir. Mir was my student. He was doing much better than you guys. I don't want to see you sitting next year, sitting in my statistics again. Next year. Okay. If you fail, then you have to sit again, second time. They were playing with their cell phone. How can I give them pass? Okay. So anyway, there is a 60% chance. 60% chance this happen. Whether truly it is 60%, no matter is the basketball rate or is the regular mortality rate, there's a 60% chance fluctuation. This is due to the fluctuation of 60%. So we consider this in the reasonable fluctuation. situation. So we say this is basically is equal to this. Okay? We cannot say the medicine is doing something good. We cannot. It could be purely by incidence. It could be purely by incidence. Okay? Now if is a 10, 12, is still 40%. Now the standard deviation is smaller from 0.2 to 0.15. And the distance, 20% now is a 1.29. 1.29. What's this is a smaller, okay? This is a 0.2. 0.2, okay? Now for the second case, one standard deviation is 0.15. If I want to draw it, I have to draw skinny. This bell curve will be skinny. This is a little fat. This is a little, from here to the waist. This is the waist, is a 0.2, okay? From here to the waist is what's here? One standard deviation. One standard deviation. 0.15. Okay? 0.15. So this is all still 60%. But here is 75%. Okay? Here is what? Is 45%. Okay? Here is 45%. It's skinnier because the M is larger. And let's say 40% still here. Okay? 40% still here. What's the p-value? What's the p-value? Calculate before you tell me the number. What's the p-value? Where? Here is the 40%. Straight down. Where is the p-value? In this part, the chance for you to scoot up. The chance for you to scoot up. This is the chance. You say you are 60%. Your average is 60%. Now is by testing you 10 times, and you got 40%. What's the chance for you to scoot up? What's the chance for you to scoot up? What's the chance for you to scoot up? So to calculate this, the red area is divided by the standard deviation is 1.29. It's not an easy number. It's not an easy number. 1.29. So we have to check the Z table. We have to check the Z table. 1.29. Anyway, 1.29. 0.4015. Can you see it?
Yes.
Can you see it? 1.2 is here. 4015. 4015. Where is 4015 means?
4015.
Where is 4015 means? It means when is a 1.29x. The distance to the center is a 1.29 standard deviation. Okay? This part is 0.4015. Thank you. This part is 0.4015. Okay. Then here we want to know the red part. This is a negative 1.29x. Okay. Then what is this area? What is this area? What is this area? What is this area? This area is the same as this area, okay? This area is the same as this area. So, from here is a 0.5, okay? 0.5 minus this is the red area. Okay? 0.5 minus this. We can almost say it's a 0.4, okay? So this is what I have here. What I have here. Okay, I didn't continue. That's good. So here is 0.1. Same is this. Same is this. Okay? So it's a 0.1. Or you can say it's a 10%. This is the p-value. This is a p-value for this case. Which means, what's the meaning? The meaning is you are 60% shooter. You are 60% shooter. The screwed up, the chance is 10%. It's less than 16% because you tried 10 times. This you only shoot 5 times. When you only shoot 5 times, you have more chance to have a lower performance. You have more chance to have a lower performance. chance to shoot 10. Still not many. Still not many. And your performance is 40%. The chance for this to be happening, is 10%. Is a 10%. Is a big chance. Anything above 5%, we consider, we can forgive, we consider you had this unsatisfactory performance is due to the fluctuation. So we forgive. We say, okay, yeah, sort of. Okay, so this is also forgiven to be 60%. Because there's a 10% chance for you to screw up. At the end of if you got your result, you fail. Let's say you fail, and you say, teacher, I just screwed up. My true score is 80. Is 80, okay? Just by some fluctuation, that day you just fluctuate. And I got into the tail, okay? You should forgive me. Believe me, I'm 80 score student. The reason I got 40 is random, due to the random chance. If you can calculate your p-value to me, okay. Now I add this. I create a question. If you shoot 10 times, listen, and you made 2. Can we judge, say, you are alive? I don't believe you are 60% shooter. Can we do that? Yes. We cannot just say using common sense. I'm sure there's a common sense, but we want to use statistics. Can you do it now? Do it now on your notebook. Do it now on your notebook. Your total shooting only made 2. Only made 2. What is the p-value? You need a Z table. I'm sure will not be exact. 0.134.
S
Standard period anyway.
P is equal to 1
Any clue? Any clue? This cannot be right. This cannot be right. So, I can tell you the result is if he only made a 2 out of 10, we can judge, we can say, sorry, I don't believe you. I don't believe you are 60%. By this, we cannot say that. If he made a 4 out of 10, we cannot say that. Because there's a 10% chance to screw up. But here, if he only made a 2 out of the 10, the chance is very, very small. And it's small enough, not very, very small.
0.126, not 134. 0.126. 126.
This is a 12.6%. Cannot be that. I already told you that this is definitely less than 5%.
Oh,
Only less than 5%. When the chance is very, very small,
okay.
smaller than 5%, not very, very small, okay? Smaller than 5%. This is the universal rule. Then we say, you are not, your center is impossible to be 60%. Your center is impossible to be 60%. Because that chance is too small. That chance is too small. All right. So this is a 20%. 20% performance. Okay? When you have made a 4 out of 10, that is a 40%. Now you have a 20% performance. Is even more lower than your 60%. Okay? This is a 40%. This is a 20%. So, point 2, first of all, this case and this case, they have the same standard deviation. They have the same standard deviation. Because standard deviation rule is P times 1 minus P divided by N. Both cases, the N is a 10. Okay? Both cases, N is a 10. This is this. It's the same standard deviation. So it's a 0.15. It's not changing, okay? Even though made 2. Okay? he only made 20%. 20% to 60%. That is 40%. Is a 0.4. Are you following me? Are you following me? So it's a 0.4 divided by, so the z score is a double, is a 2.58. Are you following me? 2.58. This is a 1.29. This is a bad drawing. 1.29 should be around here. Should be around here. Okay? So that's on proportion. So twice. So here is a 2.58. This score is a 2.58. Are you following me? Here, this is a bad, should be, I should move 1.29 over here. This is not bad. So let's say is a here is a minus 2.58. Okay. So it's a z score. Where is the z? Where is the p-value? Where is the p-value? P-value is this is a tiny bit blue. This is a tiny bit blue. The probability for this case to happen, or even worse, not just even worse, is this a little blue area? Is this a little blue area? Okay. So how to get this a little bit blue area? How to get this a little bit blue area? That blue area is the same as here. Is the same as here. Okay? Is a 2.58. Z score is a 2.58. Where is the Z table? 2.58. So 4951. 4951. What is the 4951 means? What does 4951 mean? It means this area. It means this area. Okay? This area plus the blue area is what? It is what? 50%. Okay? So my checking on that is 4951, 2.58, 4951. So 0.4951. 0.4951. And how much left for this blue? It's very small. It's 0.0049. 0.0049. Okay? This is a tiny bit blue, and this is a 0.5. Then here is the same. Then here is the same. So put in percentage is a 0.49%. This is a p-value. This is a p-value, okay? So this means if you are 60% shooter, the center is a 60% shooter. For you to have such a bad performance, for a player as good as 60%, to have such a bad luck is only 0.5% chance. Let's say this is that's rounding up to 0.5. That is only 0.5 chance for you to have such a bad performance. And when anything less than 5%, we judge original claim. No hypothesis is wrong. Okay? Then we say that this is impossible. You are lying. You are lying. If if 4 people die, we say we cannot say your medicine is good. It could be chance. There's a 10% chance. There's a 10% chance. Maybe your medicine doesn't do anything. It's just as good as this. It's just as good drinking water. However, if only 2 patients die out of the 10, then we say it is a mortality rate indeed is lower. Is lower. Could impossible to be by accidents. Impossible to be by accident. Because the chance is lower than 5%. Do I make you lost? Do I make you lost? Yes or no?
Tôi tặng.
So this is why I'm saying the p-value is the hardest and is also the most important thing. We need to have the accidents. These are in the mind. On here, we still say, okay, this could be by accident. This could be by accident because there's a 10%. Okay, but here the chance is too small. It's only this chance. We say this cannot be by accident. This cannot be by accident. You are not as good as a 60% shooter. You are not as good as